Hello all and welcome to Bitesize Insight. This is your fourth lecture on playlist of precalculus. In this video, I would like to discuss how mathematical expressions with some unknown quantity, typically denoted by x, can be solved using algebraic tools. Let's begin with a simple equation involving unknown x, and that simple equation will be 2x plus 1 equals to 7. The idea is that you try to isolate x. So 2x is equal to 7 minus 1, which is equal to 6. 2x equals 6, x is equal to 6 over 2, that is equal to 3. So what we have did is try to isolate x and solve the algebraic expression. Now you can always cross check it. Take x is equal to 3 and put it in this equation. So LHS will become 2 multiplied by 3 plus 1, which is equal to 6 plus 1, that is 7, that is equal to RHS, which implies our solution is right. Again, I'm going to write down the equation, but x will appear more than once. So let's take this equation where x upon 4 equals 3x over 5 minus 9 minus x over 10. In this equation, you will be seeing that x comes thrice. Now, simplifying RHS, we will get 6x minus 9 minus x over 10. In this, we have taken LCM. 2 is multiplied by 3x, which will further be simplified as x over 4 equals 7x minus 9 over 10. Taking 10 this side, we will get 5x over 2 equals 7x minus 9, implies 5x is equal to 14x minus 18, implies 18 is equal to 9x, implies x is equal to 2. Phew, that was rather a long process, but we have the same idea of isolating x. It was like gathering apples or oranges. We just collect together everything involving x until we just got one x. Then simplify the expressions until we get x on its own. Of course, you can check if the answer is correct by feeding back into original equation and checking whether left hand side is equal to right hand side. Now, let's consider this following equation. Now, let me change my sheet first. Let's consider the following equation. X minus 1, x minus 2 equals 0. Now, if you can see, this equation is rather quite simple. In this case, either x minus 1 is equal to 0 or x minus 2 is equal to 0. But it's sometimes still complicated why this expression turned out to be in this way. For example, suppose a rectangle of length A and breadth B. What would be the area of this rectangle? The area would be AB. Now, if the area has to be 0, either of the side length A or B has to be 0, implies if I say AB is equal to 0, then either this rectangle will become a side length of A or a breadth of B, else all area will become 0. So either in this case we are having B is equal to 0, and in this case we are having A is equal to 0. And again, a possible scenario is that this whole rectangle just converges to one point and hence the area becomes 0. So you might guess from above expressions we can do x minus 1 equals 0, x minus 2 equals 0 implies x is equal to 1 and x is equal to 2. The above expression, we can approach this equation in another way with a bit of insight. Consider x minus 1, x minus 2 equals 0. Open the brackets, we will get x square minus 3x plus 2 equals 0. X square minus 3x is equal to minus 2. Now, what I am going to do is quite fascinating. Now look at this. X square minus 3x. Now I will add 9 by 4 both sides to this above equation. Plus 9 by 4 equals minus 2 plus 9 by 4. This will further become x square minus 3x, and I can write 9 by 4 as minus 3 by 2 whole square, and the right hand side will become a quarter. Now we know an identity that a plus b to the square is a square plus b square plus 2ab. In our scenario, a is x and b is minus 3 by 2. So this whole expression, according to this identity, can be converted as x minus 3 by 2 raised to the power whole square is equal to 1 by 4. Implies x minus 3 by 2 equals to plus minus under the root 1 by 4, which is further equal to plus minus 1 upon 2. Now, the method where we add 9 by 4 to the both sides is called completing the square. Which we will also discuss further using the another example, but let's simplify it here. We are getting x minus 3 by 2 is equal to 1 by 2, or x minus 3 by 2 equals minus 1 by 2. Implies x is equal to 2 or x is equal to 1. So we have both approaches to solve the following equations. Now, in order to understand completing the square, we need to take one more example, actually what we did here. To understand this step, let me take one more example. Let me change my sheet. Now, let's take another example for understanding completing the square. Suppose I have taken this algebraic expression x square plus 6x is equal to minus 7. So in order to go through with completing the square, we take the coefficient of x, 6, divided it by 2 and squaring the whole expression. Now we get this. Now what our next step is, we have to add this expression on both sides of our equation, plus here and plus here. As if we do this step, we will actually doesn't interfere with our original equation. It's still the same. It's all cancels out. But actually what it becomes, it then becomes x square plus 6x plus 6 by 2 square is equal to minus 7 plus 6 by 2 square, which is further will become x plus 6 by 2 square is equal to minus 7 plus 3 square, that is 9. We can further write it as x plus 3 square is equal to 2, that is x plus 3 is equal to plus minus root 2, or x is equal to 3 plus root 2, or x is equal to 3 minus root 2 as our possible solution to this above algebraic expression. I think we have covered a lot of ground in this video, and it's time to sign off.